Hello friend, today I am going to discuss about the basic concept of laser, which is the part of BSc second year 4th semester physics. So welcome to the first video lecture series. Friend, laser itself stands for light amplification by stimulated emission of radiation. So light amplification by stimulated emission of radiation. So that laser must have light and which must be amplified, which is stimulated, which is a emission, and which is a radiated. So we'll discuss in the next video lecture what is stimulated emission, what is absorption emission in very detail. But today's lecture we're going to discuss about the basic important point of laser. You know friend, laser must be two things. First, laser must be a coherent source and it is a highly directional. Friends, in general, if you see about light, it is generated from one of the source. If I am talking about incandescent lamp, that lamp it is used in your home, or torch lamp, that torch lamp having the filament like this, and that filament is covered with that glass tube, and here some light is emitted from the source. Okay, so this light is emitted from the source, that means it is the radiated from the atoms present at this tungsten filament. There must be billions and trillions numbers of atom which is present in these tungsten filaments, that each and every atom can radiate the lights, and which we can see in the outside. So the light emits from the each and every atom which have the different direction, which have the different phases. So that kind of phases, or this type of light, you may say it is a incoherent. It is a incoherent because the direction of each and every radiation which is emitted from the atom is different, and there is no phase differences is maintained. Okay, but in laser we must need the coherent source, but this light is not a coherent, so that is why it is a incoherent. Okay, so why we need the coherence? Because if you talk about the coherence, the light waves from one atom which is emitted and radiated, the light waves from the second atom, third atom, so like this n numbers of atoms, so there must be the phase difference. This phase difference is zero, or the phase difference is must be constant with respect to time. Like this I'm talking about, suppose this is the first wave and this is the second waves, so this is the differences delta x. That delta x difference must be maintained during the entire time duration. As the time change, this must not be changed. Okay, so that is why the time as the time changes, this difference is maintained, or sometime this difference is very much zero, so that is known as coherent sources or coherence. And the source which can generate this type of light wave, or this nature of light, is called as coherent source. And the source which generate this type of light means which is not there is a phase differences, there is a no phase difference is maintained, there is a phase difference is zero, and here is a phase difference is not zero, and it is not constant, which is not fixed as the time change. So that type of sources is known as incoherent sources. Okay, friend. Now, what is the importance of coherent source in laser? What happened, friends, if you are using a laser source like this, suppose this is a toy laser which is available in market, and this source here is supposed to be on screen. What happened, that screen have the bright dot sharp spot. Why? Because see, these waves or light coming from the one atom, two atom, three atoms, here I mentioned only three atoms, they are just focused at the only one point, that is, it is zoom nature. This point, if we taking zoom, it will look like this. So this light, it get scattered at the particular dot sharp point, so it is highly intense or highly illuminate as compared to that incoherently. So this is the importance of coherent nature, okay, in a laser. So as I am always saying, coherence means there is a phase difference is zero. So today's topic, we will deeply understand what is phase difference and what is phases. Now let's see, here is a rigid support which is fixed, and here is a bob, a pendulum, and this is the mean position of this pendulum, supposed to be A. If I move this pendulum to the point B and then release this one, so it will get oscillate to and fro, okay, and it makes an angle theta 1, theta dash, and theta with respect to its mean position. So it is oscillating to and fro. So if I'm taking this bob from the position A to the position B and I am releasing bob, then it is come to the point A, then it is go to point C, and again it is come back to point A, and again it is come back to point B. So this whole process is continuous process. So if we draw this mechanics in a graphical nature, here must be a time and here must be a displacement. Time, and this is the displacement from this point to this point. So what happened, this point A must be here, A, and when it's come to the point B, then there is a maximum amplitude, that point is a point B, again it is come back to point A, so I can draw this one A. So from this point A, it is again go to the point C, so this is the point C, and point C, it is come back to point A. So likewise, this A, B, A, C, A, B, A, like this it is happening. So from this distance to that distance, means from A to this point A, complete cycle, the distance you must know, it is called as wavelength lambda. The time taken for this complete cycle from A, B, A, C, A, point from this point to this point, this here to here, so it is a complete cycle. So the time taken for this complete cycle, it is called as time period T, okay, and in 1 second time period, and within a 1 second, the number of oscillation is produced, which is called as frequency. That means it is 1 upon time period. Okay. And velocity is nothing but a displacement upon displacement is wavelength lambda divided by time. So this is nothing but a v is equal to 1 upon time is nothing but a frequency into frequency into lambda. So v must be frequency into lambda. So up to now we know the basic concept of this time period, then frequency and velocity. So let us take an example for how it is applicable for laser. So let us take an example of light source. So suppose this is a laser light source or any light source. Okay, so that light source which is goes like this, and this is supposed to be a sinusoidal light. Then this light must be a wave nature and it's look like this. Okay, so this is the maximum amplitude and this is the minimum amplitude. So this minimum amplitude is -1 and this maximum amplitude is +1. Okay, so this complete cycle having the angular displacement in one cycle is around 360 degree, means from here to here it is the angular displacement is 360 degree. So this is 0 degree, and of course this is the maximum amplitude here at the center. This is 90 degree and this is 180 degree and this is 270 degree, and here at that point it is a 360 degree. So which is the angular displacement in one cycle, so which I may divide it in 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. So let us first divide this length from here to here in some particular parts. This is center parts, so I can divide this like this: 1 2 3 1 2 3 4 5 6 7 8. So I divide this 0 to 360 degree in a length. That length is 8 division. So I divide this one in 8 division, which is nothing but a 360 degree, and which is the angular displacement for one cycle. So here for the sinusoidal wave, that is why the sine theta must be, if suppose it is in here it is a +1, if suppose it is in here then it is a -1, if it is 90 degree then it is +1, if it is 0 then it is 0, then if it is 270 then it is -1, if it is 360 degree then it is 0. So sine theta must be lie in between +1 to -1, +1 to -1. And if I am talking about here this point, so that means one division is equal to 45 degree, means this one division. Two divisions means 90 degree. Okay. Three divisions means 135 degree. Four divisions means 180 degree, like this. So now I know the length. One division is equal to 45 degree. Now if suppose I am having this point P here, so what is the phase at point P, which is indicated by phi? So what is phase of that point P? So I can draw a normal. So I draw this normal up to this line. So I get this is 0 point, this is 1, this is 2 and this is 3. So it is cut at the point third division. So 3 division, I cut this point P at 3 division. So that means 3 multiplied by 1 division, the value of 1 division is 45 degree, so it is nothing but a 135 degree. So which you may say it is the phase at this point P, or which is medianate phi. And if I am taking this point, this is the fourth. So finally you may say phase of wave at a point is the angle of that corresponding point. Now let us take an example of two different sources. Suppose this is a one source, having the waves like this. Here is the maximum displacement, here is the minimum displacement, like this, here maximum, here minimum. Again it is divided at 4 point, so that means for each cycle that is again divided at 8 points, so that means one division is equal to 45 degree. And suppose I have another waves like this. So this crust and crust I have to match, this trough and trough I have to match, this crust and crust, this trough and trough I have to match. So this is also again divided at 8 point, 1 2 3 4 5 6 7 8. Okay, so if I find the phase difference between these two light wave or sinusoidal wave, which is suppose this point P and here suppose the point P, that is must be, this is point 1 2, here also 1 2, so there is no phase difference, this is zero phase differences. If suppose I am draw another, this is starting from here like this, so if I find the phase differences from this point and this point, crust to crust, so I can make a rectangle between this. So here must be the difference is 1 and this 2, 1 2 1 2, so phase difference for 2 division, which is nothing but a 2 multiplied by 45, so which is 90 degree. So here must be the phase difference is 90 degree. So friend, you may now understand what is phase and phase difference, okay, which is very important for laser, okay, because laser is produce a coherent source, and this coherent source maintain its phase difference always 0 or constant with respect to time. So this is one of the very important informations in laser. I hope you must understand about the phase differences now. And in upcoming video lecture we're going to discuss about absorption, stimulated emissions. Thank you.